Welcome back, my Math Party people. Coach Anderson here. Let's go ahead and take a look at this problem, because if you're watching this video, very likely that, hey, you know this is a challenge question, and so let's understand the different concepts that we have intertwined here. That way we can learn from this and then do better the next time around. Let's go ahead and get started. No matter what, remember, the first, second, and third step to every single word problem is, what do you want? What do you have? What's the connection? So read the question first, take down your information, including those units, including what they mean, and then build a plan. So question, information, plan. Here we go. Step one, what is our question? What do we want? So let's understand that the question is revealing to us right here in the question sentence. I'm not going to read anything about this question except the question sentence. It says, how long will it take to actually fill the pool? So how long will it actually take to fill the pool? Okay, sounds good. So what we want is how long, which is time. Let's make sure we understand what kind of unit that is. Time to fill the pool. Okay, and it says actually. So maybe we can include the word actual. Because one thing you might notice is somewhere in the problem it says, hey, without the leak, the child knows that the hose can fill the pool in 90 minutes. So that's not the answer, everybody. That is not the answer, because it says without the leak. So apparently somewhere in this problem, there's a leak that we're going to discover, and we have to understand what that leak has to do with it. So let's take everything nice and slow. We need to, and I mean need to, understand the situation appropriately, so that way we don't have a headache after this. We still might have a headache after, but we're growing. So here we go. So again, step one, what do you want? We want time to actually fill the pool. Okay, step two, what do we have? What information do we have? Before we continue, just want to take a quick moment to thank you for watching this video. And all I ask is that you please like, comment, and subscribe to the channel. That way more people just like you can see these videos. But on top of that, if you're looking for more ways to practice the right way and raise your score with guidance without stressing, then I really wholly 100% recommend my ASVAB All-Access Program. The program, long story short, helps you watch, practice, and master every topic, from the word knowledge to paragraph comprehension, arithmetic reasoning, math knowledge, general science. It's there and it's designed to help you succeed with practicing the right way. So with that said, check out the link in the description to see how it all works, because you're going to have ways to learn in every way that you prefer. And you get my guidance and my support all the way until you pass. So don't hesitate. Stop feeling nervous and being anxious and letting yourself feel that way when there's a solution waiting right here for you. Check out the link in the description. That way you see how it works. And then reach out to me if you have any questions about it. Let's get back to raising our scores. Let's go ahead and just read through the story. Remember, when you read through the content of the problem, it's best to ignore the numbers, but read around the numbers. See what the numbers mean, and then write it all down. Because you might get hung up on a percentage, a decimal, a fraction. Don't worry about that until you know what it means, until you know why it's there. So let's go ahead and take a look here. So an above ground pool has a leak at its base. Oh, that sucks. That sucks. And it's causing it to lose 25% of its total capacity per hour. A child notices the empty pool and uses a hose to pour water at a certain rate here. Without the leak, the child knows the hose can fill the pool in 90 minutes. How long will it actually take to fill the pool? So let's understand the story really quick, because again, that's a lot. Notice we threw percents in there, we threw a rate in there, we threw minutes in there. There's so much going on, right? And that's why it's a challenge question, and that's why I really am happy that you're watching this video. So here we go. So the leak causes it to lose 25% of its capacity per hour. That's crazy. A percentage as a rate? What? Okay, let's go ahead and see what we have here. So again, the leak causes it to lose 25% of its total capacity per hour. Okay, sounds good. So if we knew the total capacity of the pool, 25%, remember, 25% is a fourth. Divide by 4. So we could figure out the rate per hour that this pool is losing water. We could find that. But let's just take down the information first, though. Again, the leak, it causes the pool to lose, so I'm going to point a down arrow here, it loses 25% per hour. Okay, so 25% of what? 25% of the total capacity. So let me just write that over here. 25% of total capacity. Very important to write that because the total capacity is the amount of water that the pool can hold. So let's make sure that's very clear for us. Let me move this over here. Cool. There we have that first piece of information. Again, take it one step at a time. Let's see how we can connect this. A child notices the empty pool and uses the hose to pour water at a rate of 6 gallons per minute. Okay, so child, okay, pours. I'm going to draw that right over, let's go ahead and say here. So this is little Timmy over here. And Timmy is using a hose to go ahead and fill the pool up at a rate of 6 gallons per minute. Okay, sounds good. So plus 6 gallons per minute. Again, I'm just visualizing it, right? Just having a little fun with it. But we're filling that pool up at a rate of 6 gallons per minute. And you can consider that a rate. Again, it says it right there. A rate of 6 gallons a minute. So we can absolutely perceive that as a rate. But what does it say here? Without the leak, the child knows that the hose can fill the pool in 90 minutes. So without leak, so let's write that over here. Without the leak, 90 minutes to fill the pool. But again, we're looking for with the leak. And again, that leak is causing this pool to lose 25% of its capacity per hour. So this is a mental nuts problem. Why? Because here's the thing. You saw that we were given a rate right there for the child putting in the water in the pool. Then we also saw the leak. 25% of the total capacity per hour is being lost. That's another rate. Again, per, the word per gives away that that is also a rate. So what are we supposed to be doing with these rates? We're supposed to subtract the rates. How do I know that? Because if we're trying to figure out the time that it takes to actually fill the pool, we need to understand the difference between the water being poured in and the leak coming out. So I'm going to show this right over here. This is my leak. There's a leak right there causing water to spill out. Causing water to spill out. So the water, the rate going in minus the rate coming out is the net that you get, the net water going in, because there will be water pouring out with the leak. But it's possible, which it is in this problem, that the water coming in is more than the water going out. So it will fill up eventually, but we need to figure out what that rate is. And the way to figure it out is to subtract the rates. We just need to figure out what this is in terms of gallons per minute. We have to write it the same way. So the age-old question is, how do we get there? Well, the thing is, if this is a rate problem, we need to understand distance equals rate times time. That's what we need to understand. And in this formula that we're using, remember, every piece needs to represent the same scenario. So if we're looking for the time with the leak, we need to find the rate with the leak and how much water the pool can hold total, even with the leak. How much water is it going to take to fill it up? So there it is. Distance equals rate times time. All three pieces need to be represented the same way. So let's go ahead and understand. First, can we find the distance here? Yes. Remember that distance is also considered any amount, not just a distance like feet or yards, but an amount like the total gallons. It's the amount you're trying to achieve. And the way that we get there is this. Right over here, without the leak, 90 minutes to fill, and the rate without the leak is 6 gallons a minute. Because again, little Timmy over here knows that if I pour 6 gallons a minute, it'll take me 90 minutes to fill it up. So I can actually apply the distance equals rate times time formula over here, again, without the leak, to figure out how many gallons the pool is supposed to hold. And that's going to be super easy because distance equals the rate, 6 gallons per minute, times 90 minutes. Again, minutes, the units match up. So then that's going to give us total gallons. What's 6 times 90? That is 540 gallons. The pool can hold 540 gallons right behind my big old head. And so for a brief moment, I'm going to move myself over here, and you'll see that right there. 540 gallons is the distance, is the total amount that the pool can hold. Now, why does this help us? Because, my math party people, guess what earlier? Earlier, we were told that the rate for the leak was 25% of the total capacity per hour. So what does that mean? Well, guess what? Remember that 25% is equal to a quarter. If you didn't know that, you must know that. Because remember, to go from 100% down to 25%, you divide by 4. Always start from 100%. So if I divide this 540 by 4, I will understand the leak in terms of gallons per hour. So with that said, let's get it done. So 540 gallons, let's divide that by 4. What are we supposed to find out here? 4 into 5 goes once. Bring down that 4. Let me zoom in a little bit here. Then we have 4 into 14, that's going to be 3. So minus 12, that's going to give us 2. Bring that 20 down, boom, that's 5. So that's going to be 135 gallons per hour. That's what the leak will contribute to. 135 gallons per hour. Okay, sounds good. So let's go ahead and write that out over here. The leak, again, translates. Let me bring myself back into the picture here. So the leak will contribute, again, 25% per hour. That's the same thing as saying this. 135 gallons per hour. Okay, great. And so what am I supposed to do next here? Well, what I'm supposed to do next, my party people, is this. I need to show that I understand that, hey, look, the leak earlier, let me go and show the leak again. The leak earlier was 6 gallons per minute, but this is gallons per hour. Our answer is going to be in hours. So there's a lot going on in this problem. And so what I'm going to do next is I'm going to try to find out what 6 gallons per minute is in terms of gallons per hour. So allow me to come up here real quick, and I'm going to say, hey, 6 gallons a minute. Let me write that in the same color. 6 gallons per minute. How do you go from gallons per minute to gallons per hour? You multiply by 60. Because 6 gallons in 1 minute is 12 gallons in 2 minutes, 18 gallons in 3 minutes, and you keep going. So you're going to multiply by 60 to fill up 60 minutes to find out 1 hour. So here, times 60, and that's going to equal, right here, 360 gallons per hour. Booyah! Now that we have the fill rate per hour and the leaking rate per hour, we subtract them to get the net water going in per hour. There we are. So this is a lot, right? It feels like a lot, and that's why this is a challenge question. So with that said, let me move this out of the way. Let me move this over here somewhere. And then from here, what we're going to do is we're going to find the total rate. So my rate is going to be this, right over here. Rate equals the 360 gallons per hour minus the 135 gallons per hour that we have right over here. And that's going to give us what? That's going to be 225 gallons per hour. Okay, great. There we have it. There we have it. We have a rate of 225 gallons per hour. That is the net rate. With the leak, that is the rate. So right here again, this is the rate with the leak. So we have everything we need, everybody. We have everything we need. Remember, the distance, 540 gallons. That's how much the pool holds. The rate that we have is 225 gallons per hour with the leak included. And now we can find the time because we're going to apply the distance, rate, time formula. So I'll go ahead and apply the final formula right here. D equals RT. Again, with the leak, we have 540 total gallons, 225 gallons per hour times time. The only thing we must do now, my party people, is divide both sides by 25, and we have our final answer. So I know I did a lot of explaining, but hopefully that gives you a better sense of understanding that this was a rate problem, but it was mixed in with percents and a little bit of unit conversions. That's what made this pretty tough. So let's go ahead and finalize this. We're going to cancel out the 225, and we just need to figure out what this is. But let's be smart about it. Look at our multiple choice options. We have 1.5, 1.8, 2.4, and 2.75. So with that said, let's go ahead and divide and see if we can eliminate choices as we go along. So here we go. 225, I'm gonna write this over here. I'm gonna give myself a little more room by deleting this. And here is your regularly scheduled announcement, my party people. Remember guys, I host a free class every single week and more classes beyond that. So make sure to check the group tutoring schedule so you know when the classes are, when you can expect to see me live so you can raise your score and get that job you want. So click there to see the schedule, and let's keep getting back to the YouTube video right over here. So 225 into 540. Well, 225 goes into 5 no, 4 no, 54 no, 540 yeah. It'll go in there a total of at least 2 times. Because 225 times 2 is going to be right here 450. So that becomes a leftover of 90, and we must use a decimal here. So bring that 0 down and we have 900. How many times does 225 go into 900? The answer there is going to be 4. Because right over here, if I do a little test, 225 times 4, that's 20. That's 8 with the 2, 10. 2 times 4 is 9 plus 1. Or 2 times 4 is 8 plus 1 is 9. And so that's 900. So that would be 2.4 hours. And that's the amount of time it takes to fill with the leak. And so there we have it, my ASVAB, or my party people here, my math party people. There it is, 2.4 hours. C is the answer. So let me review this with you before you sit here and say, man, my head's spinning. So this was a rate problem. The reason I knew it was a rate problem is because we were trying to find the actual time it took to fill the pool. So that means that there's an actual rate and there's also an actual amount that the pool can hold. The amount that the pool can hold, we could figure out easily because we were told, hey, the kid is pouring the water in at 6 gallons a minute, and he, without knowing about the leak, says that it'll take 90 minutes. So you can use distance rate time before, again, to find the 540, because distance rate time, hey, 6 gallons a minute, 90 minutes without the leak, that's 540 gallons. Boom, that's the same distance as all the way over there. We figured out the distance. We're looking for time. What's the rate? Oh, it's losing 25% of its capacity per hour. Well, what is 25% of the capacity? Well, 25% is divided by 4. The capacity is 540. 540 divided by 4, that became 225. Boom. Right there, or divided by 4, that was 135, excuse me. That was 135. And so, to find the actual rate, subtract 6 gallons a minute minus the 135 gallons an hour. But that didn't seem right because we were given gallons per minute. To get it in terms of per hour so that we can actually subtract, we multiplied by 60, got 360. So that was the actual fill rate in hours, in gallons per hour that the kid just does by himself. But we had to take away the leak because leaking means we're losing water. And that's how we got the 225 gallons per hour. So now that we had the total amount that the pool can hold, the 540, the rate that we're filling it at with the leak present, 225 gallons per hour, we're looking for the time in hours. Everything was set up perfectly. And so we set it up here, 540 equals 225 times t. Distance equals rate times time. This all represents with the leak. Boom, divide both sides, do some math, and we are done. And so I'm not gonna sit here and say that this is easy. It absolutely is not. But by showing you these challenge questions, I'm showing you how complicated, how potentially complicated this can be for you. But if you can handle a question like this in less than 2.5 minutes, 3 minutes, you're in a pretty good spot. Like if you can handle a question like this, you can handle percents, unit conversions, and distance rate time all right there in one. So if you can do this, feel proud of yourself. Even if you didn't use a timer, even if you did it eventually and you took your time by yourself, be proud of that because it shows that you have what it takes to basically learn from every situation and understand that if you're looking at a new problem, you can still figure it out. So again, I'm Coach Anderson. Let's look forward to the next video coming up soon and let's keep getting smarter. Keep asking why and let's keep growing. I'll see you soon. And before you go, if you like what you saw and you want to raise your score with thousands of practice problems just like that so you can lower that test anxiety, raise that confidence, go to this link right here to check out the full program. There's a video that shows you exactly how it works. but you're going to get lessons, guided practice, worksheets, speed drills, and everything that you need to feel supported from day one all the way until you pass. Again, I'm Coach Anderson, and I'll see you soon.